In Chapter 5, we will be studying logarithm and exponential derivatives and integrals. I thought it might be helpful before we actually studied those if we were somewhat more familiar with working with logarithms and with exponential functions. So, at the end of this lesson, you'll be able to use the properties of logarithms to simplify and unsimplify expressions. All right, let's go ahead and look at logarithm properties. You've had these before, but let's just see if you remember them. This one says log base A of 1. The biggest thing on this one, the word log, is just an exponent. So it's basically saying if the exponent with a base of A, so it's basically saying A to the what power question mark, would give me an answer of 1, and we would know that that answer would be 0. So the log of 1 is equal to 0. The next one, if I have the log of a base A and I have a quantity that's being multiplied together, we can go ahead and separate that into two different parts. So we can make this log base A of x plus log base A of y. This will help it make it easier for us when we actually go to take a derivative if we use that property. The next property that we have, if we have log base A x to the n, one thing that you learned before is if we can take that power and we can bump it out front. So another way to rewrite this problem would be n log base A of x. All right, and then this last one, just similar to what I did in number 2, if we have multiplication, we can separate it into two logs with addition. If we have division, we can separate it into two logs with subtraction. So this would be log base A of x minus log base A of y. All right, let's see if we can, natural log properties. The natural log of 1, if you remember the natural log, it's actually has a base of e. So in this first example, basically what's that saying is that e to the what power would give me an answer of 1. And again, that's just going to be 0. So either the log of 1 or the natural log of 1, they are both 0. Okay, property number 2, very similar to property number 2 in the previous example. If I have natural log and it's of a quantity that's being multiplied, I can separate it into ln x plus ln y. Okay, same thing as property number 3 on the first example. If I've got a power, we can bump the power out front, so this can be rewritten as n ln x. Okay, and then if I have ln x divided by y, same thing as before, we can separate it with subtraction, so I'll have ln x minus ln y. And then my last property, ln e is equal to what? We will use this quite often, and basically what this is asking me is if I have the base of e, what exponent would give me an answer of e? And we can see that that answer would have to be 1. So whenever you see the natural log of e, we know that that answer will be 1. Okay, let's go ahead and try some examples here. It says to use the properties of logarithms to write the expression as a sum, difference, and or multiple of logarithms. So basically what we want to do, it's written in one form right now, we actually want to write it as two different problems. Since there's division here, we know we can use the property where I can separate them with a subtraction sign, so I can rewrite this as ln 1 minus ln 5. And I actually can go one step farther on this one because we know that the natural log of 1 is 0, so my answer would be negative natural log 5. Okay, this next one, the first thing that I'm going to do is to rewrite this. I'm going to rewrite this as log base 3 x minus 1 to the 1/2 power. Okay, the next thing that I'm going to do is just to bring that 1/2 out front. So if I bring that 1/2 out front, I'll have 1/2 log base 3 of x minus 1. And I could not go any farther on this one because this is subtraction, it's not multiplication or division inside. All right, let's try some more. Okay, this next one, you might be tempted to bring that squared out front right now, but the problem is the squared is only on the e, so we need to separate it first. So since this is multiplication in between the 3 and the e squared, I'm going to rewrite this as the natural log of 3 plus the natural log of e squared. Now I can use that power rule to bump the 2 out front, so I'm going to have natural log 3 plus 2 natural log e. We do know that there's a property that says the natural log of e is equal to 1, and so my final answer will be the natural log of 3 plus 2. Right, example 4. The first thing that I would like to do on this one again is we don't like to work with square roots, just like we didn't like to work with them before, so I'm going to write it as a power. So I'm going to have log base 2 x times x plus 2 to the 1/2 power. Okay, now again, just like in example 3, I don't want to bring that power out first because right now two expressions are being multiplied together, so let's separate it first. So I'm going to have log base 2 of x plus log base 2 of x plus 2 raised to the 1/2. And now you'll notice on the second set, I can bump the 1/2 out front. So my final answer is going to be log base 2 of x plus 1/2 log base 2 of x plus 2. And again, what this is going to help us with is if we have to take the derivative of the log function, which we will, this will make it easier for us to actually take the derivative. Okay, let's try going backwards this time. Right, this time you'll notice that I have it as 3 separate logs. We're going to try to write it just as one ln. So kind of working backwards, if we've got a 3 out front, I can bump it to the power. So this will be ln x cubed. Plus, again, we've got 2 out front, so I'm going to rewrite it as a power. So we'll get ln y squared, and then minus. The 4 was out front, so I can bump it up to a power, so it'll be ln z to the 4th. And now from here, since I've got a plus sign, I'm going to write the word ln one time. Since there's a plus sign, I know that I can multiply those quantities together, so x cubed y squared. And since there's a subtraction sign, I know that I can divide, so I'm going to divide by z to the 4th. So it's going to be the natural log of that entire expression. Okay, let's do one more here. I'm going to ignore this 1/3 until I'm all the way done with the problem. First thing that I'm going to do, there's a 2 sitting out front, so I know I can bring that to the power spot. So I'm going to have log base 4 x plus 3 squared. Nothing I can do with this next one really. And nothing I can do with the next one. Okay, now I notice that I have 3 different parts being separated by a plus or minus, so I know that I can multiply and divide. So I'm going to write the word log one time. And when I do that, I'll have x plus 3 squared. And then since I'm multiplying, since there's a plus, I'm actually multiplying by x. I'm going to write it out front. And then since there's a subtraction sign, I know that I'm going to be dividing by the x squared minus 1. Okay, and one thing I am going to do, this 1/3, I'm just going to tag it along now to my answer. And then there's actually one more step that I can do. I can actually bump this 1/3 to be in my power. So it's going to be the 1/3 power of this entire expression. So I'm going to rewrite this as the log base 4. A 1/3 power is really a cube root, so I'm going to write a big cube root sign of this entire expression. And that would be my simplified, I guess if you could call it simplified expression. So now hopefully you can use the properties of logarithms to simplify and unsimplify expressions.